What's going on, y'all? My name is Alex, and today I'll be talking about, for my current event, fridge-free COVID-19 vaccines that were recently grown in plants and bacteria. This comes from the University of California, San Diego. I'm going to try to pronounce this name. Lizel Labios is the author behind this article, and this article was published on September 7th, 2021. All right, so just a little bit of a background into this research. So COVID-19 vaccines are currently required to be kept in cold temperatures due to their instability, and they require constant refrigeration and cooling in order to maintain the stability. However, it's not possible or feasible to keep them in the cold in certain regions of the world because they require certain fridges and freezer trucks to keep them at a certain temperature, so that way they don't lose their stability. And then this makes global distribution difficult when trying to keep them cold, and this in turn also makes it quite expensive as well. All right, so the research methods that went into the vaccine. So they developed vaccines from plant bacterial viruses and injected them in mice. And then to test this, they used cowpea mosaic virus, as you can see right there on the right. That virus there, that is the cowpea mosaic virus. And then they also used Q beta bacteriophage in E. coli. And so what they did was they attached a small piece of the COVID spike protein to the surface of the nanoparticles that were produced containing these two viruses. And then, so what happens is that it appears infectious to the immune system, but then your immune system recognizes it and knows how to fight it off, and then it simulates immunity production. So once you are infected, if you are infected with COVID-19, then you're actually able to fight it off because your immune system recognizes those spike proteins. All right, so the results of this study found that immune systems of the infected mice were able to fight off the infections caused by SARS viruses, including SARS COVID-19. It was easy and inexpensive to use, primarily because E. coli is really relatively easy to reproduce. And then also the plants that were grown for those mosaic viruses, growing plants is it's pretty easy, doesn't require a whole lot. And so it's really, really easy to reproduce. They can last and remain stable in close to almost 100-degree Celsius temperatures, which is really great for especially places such as the Middle East, central parts of Africa, places where they would have quite a difficult time receiving cold electricity for cold temperatures to maintain those cold temperatures, and where they would be trying to distribute them, those vaccines. It makes it really, really easy and feasible for those regions. And then it can be administered using 3 different methods. One of them is a series of 2 vaccines like we're used to at this current time. Also vaccination implants, as you can see on that top picture. It's a slow release tabloid, and then also microneedle patches, as you can see for the bottom 2 pictures, which slowly inject the vaccine without pain or discomfort. And it's really easy for self-administration. So all patients have to do is just simply apply those small patches, and those little needles that you can see down there at the bottom, they contain the actual vaccine itself. So it's a really slow and continuous process that's being inserted into your immune system. All right, and then looking to the future with this, so current studies are being done to observe the effectiveness against the Delta variant that's currently out, as well as other variants. I know right now the CDC had announced that they're watching the Mu variant, and so I believe that they're likely probably testing onto that variant as well. They could possibly lead to safer and cheaper alternatives for mass global distribution because of the greater stability of these vaccines. And then they actually said that it could be applied to other future viral infections, and a quote plug and play, basically where they would take a part of those future viruses, future infections, and actually be able to use that in this same manner and be able to prevent these infections later on. And then right now, clinical trials are far off, but they're really hopeful that they will eventually be able to distribute this and start using clinical trials in people, which would make it a lot easier on a global mass scale.